Alright, so the main point of focus in this video tutorial today is going to be how to integrate the Shinami Gas Station. Shinami is, to my knowledge, the #1 node provider on the SWE network right now. I think there are others, but I'm not entirely sure what they're called. But Shinami is the only provider of this gas station feature that I'm aware of. And again, what the gas station is it lets you pay your users gas fees. So if I want to use SwePlace, I never actually have to. I still have to have a wallet, but I never have to buy any gas. I never have to have any SWE to actually use to assign transactions, and that's what we're going to be integrating today. So to understand, let's just take a little bit of time to understand how exactly this works. So when we think about what we're doing right now, right? Like we have this flow. So let's say that we're in the program where we have the XY color and we want to make a transaction. Make a transaction. Well, so what we do right now is we construct this TRX, we construct a transaction block, right? PTB, which is a PTB programmable transaction block. Then we call wallet.sign and submit transaction. And I actually forget if it's called sign and submit transaction, right? But it's something like this. And we just call some function that Ethos gives us, and what it does. Here's what happens behind the scenes, right? So from our perspective in the code, what we're doing is we're passing it this PTB, and we pass it the PTB, and then since it's a function of wallet, it also had access to our key pair. So this wallet.sign and submit transaction, what that's going to do is it's going to first off, it's going to take JS object of transaction block, then it's going to convert that into a what's called the binary serialization format. Convert that into serialized format. And what that means is that so in SWE, right, there's the interface that we think about and that we use, right, and that's all in JavaScript. But then there's also this format that the validators all think in, right? There's a serialization where they make it instead of using JSON, they make it very they pack things really tightly together. They don't have any kind of extraneous data, and that's all to make it super fast, super optimized. So we need to take this JavaScript object and the interface that we're used to, and that's what this wallet sign and submit transaction does, to start off with. And so we have convert that into serialized format, and we're going to call that like transaction bytes. And another thing is that we need to associate a gas object. And the way that gas works in SWE is that, again, we have to give it a object that's a coin. So we have to give it coin of SWE, right? This is just the regular SWE token. And then we're going to say, hey, we're going to tell the validator, hey, whenever you're running this transaction, you can take, in order to pay yourself for gas, you can take some money out of this coin that I'm giving it to you. And then what we do is we sign that transaction. And again, a signature. What the signature does is this is where the cryptography comes in, and this is what tells the world. It says, hey, this public key, this SWE address is saying I approve of this, I authorize this transaction bytes. And I'm saying this transaction bytes is okay with me, and what the validator interprets that as is, okay, I'm making that transaction. And then the fourth thing is that after it has this signed transaction bytes, it's going to send it to the RPC. So what that's doing is make HTTP request to RPC URL with that signed transaction bytes. So you can see that with this wallet.sign and submit transaction, it's taking care of these 4 steps where it converts it to a serialized format, it finds the right kind of gas object, it signs the transaction, and then it actually makes the HTTP request that sends it to the RPC. So we need to do it a little bit differently, and the main reason is because we need to specify, the way that this RPC, the gas station works is, so we want to do gas station to pay for users' gas fees. And the gas fee works because, or this works because we have a gas fund. And in Shinami, so Shinami owns and manages this gas fund. So we have this gas fund that we have to supply. And so what happens is the front end still has to, take JS object, convert into transaction bytes. But this is where we're doing things a little bit differently. Instead of having the wallet, like this Ethos Connect, in the front end find the gas object for us and put it on the transaction, what we're going to do is we're going to send transaction bytes to our Lambda. Our Lambda makes request to the Shinami service with our API key, and so that's how Shinami knows that we really are authorizing this this transaction to use our gas. And then Shinami associates a gas object with the transaction bytes given to Lambda, given by the sender. And this actually results, I'll make a new indent there, is this actually, this step number 4, this results in a new transaction. It's the same transaction that the end user builds, but the difference is that it has the associated gas object. And then with that, and then the user has to sign, so the Lambda returns Shinami transaction with the gas object associated. Then the end user signs the transaction, the new transaction, and then the Ethos are just going to send it to the RPC like normal, right? Send transaction to RPC like normal. So before we start, we're actually going to get this set up on testnet, right? Right now, we have our sweet place, and that right now it's running on DevNet, but we actually want it to run on testnet. And I'm going to show you, and actually just went ahead and did that right before writing this document. So I'm going to show you there's really only 3 things that you need to change. It's super easy. So the way that we're going to do that is we go to our source, and then we go to the script that we made. Whoops, not source. So we go to front end, we go to scripts, and then we go to this deploy.ts. And before we had fullnode.devnet.suite.io, and we want to change that to fullnode.testnet.suite.io. And again, what this Suite client in this URL, like this RP URL defining is, right, we're deploying all these transactions, we're doing this kind of stuff. Before we were doing it on DevNet, now we want to do it on testnet. And again, the reason why we're doing this, we need to change this to testnet, not DevNet, is because we have this gas fund. And the problem with DevNet is that because it resets pretty frequently, right, whenever they update the chain version, it's pretty hard for Shinami to maintain that gas fund and make sure that it stays there. Whereas since the testnet maintains value across resets and like all the objects are going to be the same, then it's not like this isn't as big of a deal. But that just means that Shinami isn't going to support this on DevNet, while they do on testnet and mainnet, of course. And that's all we need to do. So we can actually go back to front end, and we can do npm run deploy. And another thing to note is that you're going to need some testnet tokens as opposed to DevNet. So far we've been doing this on DevNet, but we want to make sure that we have enough testnet tokens for this to work. At the moment, unfortunately, I'm not entirely sure if the faucet works. Testnet faucet I've always found to be more difficult to use than DevNet faucet, and that's why I prefer to work on DevNet, honestly, just because the faucet's easier. But I think even today they used to do it on like by Discord. They might still have the Discord bot where you can get testnet tokens, but I would just recommend Googling like how do I get testnet tokens suite, and that's probably going to be the best documentation there, because it seems like this is something that they're changing and trying to improve. And I'm not entirely sure that I'd be able to give you the best advice for if you're watching this in the future. So now that we run the npm run deploy, we do have a new updated deployed objects.json, and that's going to be here. And we can, it's good to, so we scan.xyz it's good to verify that on the SWE scan, just to make sure that you did it correctly. It looks like, since they just updated the chain, it looks like it's still syncing. It says Explorer data may be incomplete. But what you can do is you can do the SWE client, and I already set this up, so SWE client ends. So you can have multiple environments, and this represents like the chain that you're on. So previously we've been doing things on DevNet, but you can set up a new chain to switch your SWE client to with SWE client, what do you call it, right? SWE client new env, and you can run like SWE client new env, and yeah, then it'll tell you what arguments to put, and then SWE client switch. You can use SWE client switch and then set the environment and be like, oh, SWE client switch environment testnet or environment devnet, and that's going to switch. So then when I do SWE client gas, this is showing me all the tokens that I have on testnet rather than on devnet. Since it isn't showing up in the SWE scan, since it hasn't synced, it will actually sync in our SWE client. This is going to be a little bit more up to date. So we can do SWE client object, and then this is going to be one of the quadrant IDs. We can check it. Yeah, it prints out this big list of white pixels with the ID, and it says this is the first quadrant ID, which makes sense. Perfect. The other thing that you need to update is in this, again, this app.tsx, or not TSX, and get place board, SWE place indexer, get place board, this app.tx, and the lambda that we defined previously. You're going to want to change. Previously we were using DevNet, and now we're using testnet for the SWE client. So recall back in this wallet flow, right, steps 3 to 5, we need a lambda. And the reason why is because in order for Shinami to know that we're authorizing and say, hey, this transaction, it's okay to use our gas fee, like our gas fund for this specific transaction, we need to give Shinami our private API key. And again, we need to keep that API key private, because if somebody has it, and they can just steal it, and they can make whatever calls they want, and then that's going to steal up all of our gas fund. And that's why we're using lambdas, is to keep this. We're going to keep the API key private inside the lambda, so that way it never gets exposed to the public. So that's why we need to make a new lambda. And making a new lambda in AWS is a little bit confusing. Specifically, the way that we're doing it is we're using with this SAM model, and that's going to give us this template.yaml. In this YAML, we have resources. So this is what's going to define like the things that are associated with this project, with this AWS project. And I actually changed a little bit of this code since last video. Before, we just left this as like hello world, and we said, like, oh, this is hello world API, hello world function, and I changed that to be get place board API, just to make it more clear. And this is going to define the serverless function that we're using. Specifically, so what this is saying is, so one of the resources that we have associated with is this get place board function, which is a type of serverless function. It has some properties. For example, the code URI, which is the folder where the code is located in, is in this. It's in this get place board folder, and we also have these get place board APIs and functions and IAM roles, which is going to be useful for making Lambda integrate. And again, it's I'm not entirely sure. Like all the ins and outs of like what exactly everything needs to be here, right? AWS is really complicated, so just get it to a place where it works, and then just improve it incrementally. So what we're going to do in order to add a new function is we're going to copy paste this get place board function, so all the way over here, and we're going to call it get gas list trx function. So that's what we're going to call this new Lambda function, right? Because it's taking the function it's taking the transaction bytes that the front end is going to give us, and then we're going to return the transaction bytes that Shinami says, hey, this is where the gas is associated with this function, or with this transaction. And so it's still the same type, it's still a serverless function, but we're going to actually copy paste this. So copy paste, and we're going to rename it to get gas list trx. Whoops. Get gas list trx. We're also going to delete this deployed objects JSON, because that only exists because we copy pasted it. Just just hit no for that. And we can also update the package, get gas list trx. And so now when we go back to this template.yaml, so we changed get place board. This is going to be not get place board. We want it to be get gas list trx. So again, this is going to be the folder where the code is located. Keep all this the same. And then this is the path. This is going to be like the endpoint, like the slash at the end of the URL. And again, we just want to do the same thing. Get gas list trx. Another thing that we're going to do is we're going to copy paste these things. And we're going to change, so get gas list trx. And I'm gonna change everything to reflect the new name. And also note that you need to replace, like for example in this URL, we're going to replace it with the new URL too. So not only these, like the things in the blue, but also the strings. So now when we go back to our get gas list trx, we have this new app.ts, which is going to define a totally new lambda, and we're going to double check and make sure that this works. And we're just going to delete everything. Just for example, we're going to like return, hello, or no, that's right. We need to return status code of 200, and then a body of like whatever we want the body to be. So hello world. And then again, we're going to do sam build and sam deploy, and then just press yes when it tells you to do the change set. Whoops, folder. So just press yes when it tells you to accept the change set, and then yeah. So it tells us it successfully created the stack, and we also have this get gas list trx URL, which when we call it, yes, we successfully have this hello world message. So now when we go back to our flow, we're going to want to change it from just using the simple call to kind of going through these steps more explicitly. And so again, recall we're doing this in the quadrants, and so this is going to be the canvas where all the pixels are actually drawn onto, right? And again, we have this on click where it calculates the right X and Y. It checks if the control key or the Apple key is held down, and then before we had this, the wallet dot, actually, what was it called? It was wallet dot, yeah, sign and execute transaction. Well, not sign and submit. Yeah, but same idea. So we had that previously, but now we just deleted that. This is going to be the exact same transaction block, and so now what we need to do instead is we need to use this wallet dot, or no, it's not wallet dot build. It's trx dot build. So dot build, and we need to give it some options. We need to give it only transaction kind of true, and again, the reason why is because we're going to be like what this trx.build does is we have this transaction object, and we want it to build it into the bytes, this serialization that we're talking about earlier. If we don't have only transaction kind to be true, it's going to try to find one of our gas objects, right, one of our sweet tokens, and use it inside of this build. But we don't want that, right, because we're going to do that. We're going to handle that later in the Lambda. So that's why if we set this to true, then it's not going to attempt to find one of our gas objects and put it on the serialized string. And then the other thing we need to do is we need to give it our wallet, and we can do that with client. We can get that, we can get that from our wallet. Great, and then we assign that to a variable. And this is a promise. Looks like that's an async function, so I'm gonna make this smaller. And I'm actually gonna make this, oh wait. Did this work? Yeah, so now it's a uint array instead of a promise of uint array. And this is only possible because I added this async. I made this this callback in async, and that's why I can use this await syntax now. So now that I have this TRX bytes, again, recall the next thing is we need to send those TRX bytes to our Lambda. And the reason, and we already have this Lambda, and we're just going to do that through a query parameter. So instead of instead of, at the moment we're calling it like this, but we're going to add like TRX, TRX bytes equals, and then like, you know, whatever the transaction bytes are going to be. So we're going to do it through one of these like query parameter style. And so first off, let's get the URL that we want to, let's set this URL to be a variable here. And we're just going to do that copy paste. We want to copy paste this. Again, I'm sure there's a more, you know, a more recommended way of getting this string embedded. I'm sure there's like AWS gives you some tool of getting a string from here from the SAM tool and putting it in to your front end URL or saving it as an environment variable somewhere. But we're not going to bother with that because I don't think it's super relevant to Sui. It's more of an AWS specific kind of thing. So yeah. So that's our URL, and we're also going to want to do URL dot search params, and we're going to want to add, or we're going to want to append one of the search params, and we're going to say, yeah, so TRX bytes, this is the name, so TRX bytes, and then the value is going to be this actual TRX bytes variable as uint data array. So right now, if we just try to submit it like this, I don't believe, yeah, it doesn't compile. It says it's not, uint 8 array is not assignable to parameter of type as string. So what we're going to do is we're going to use this new text encoder from our, we're going to say UTF-8, and then we're going to encode, and we're going to say TRX bytes. The parentheses works, and we get a little bit of an error. What is going on here? Oh, looks like I used the wrong, instead of encoder, it's actually going to be text decoder, and then we're calling the decode method on that, and then that's gonna, this is gonna give us a string instead of a uint array. So now we want to send this to the Lambda. So we're going to do const response await fetch. Right, this fetch is just an HTTP request, and we're going to pass it the URL, and that is all we need to do. And then we're going to want to console log the response, so we know what's going on. So let's go back to our SweetPlace indexer. Let's go to our app.ts. And so once we're in this Lambda, the way that we can get query params is we can do event dot path parameters, or no, query string parameters, and then we can we can do this. This is the this is like the conditional, or this is like the nullish like property access. So this has a value of either this thing that we can query or null, and so we called it. And yes, we called it TRX bytes, const transaction bytes equals that. So this is going to be string or undefined. And if it's undefined, if not transaction bytes, then we actually want to return an error. So we're going to want to return status code 400 for that's a bad request, and a body of need to include TRX bytes. And let's actually make this a JSON so it's consistent. So JSON dot stringify error need to include TRX bytes param. So there's actually a step. There's another step here that we want to do, but we're not going to because it's not. It's just not really necessary for us because we're on testnet, and that's we want to probably validate transaction bytes. And what we want to validate is we want to validate that it's our move function. So what we would do is we'd take this transaction bytes, we'd deserialize it into a uint array, and then we with like the BCS library that Sweep gives you, and then we'd want to double check and make sure that the only thing that this does is call the place. Right, we go back to our contracts. We want to make sure that it's a transaction that the only thing it does is call this set pixel at public function. And the reason why we want to check that is because right now, if somebody, like, they know our source code because it's public, they can recognize, hey, we don't validate it, so I can just get you to pay for any kind of gas that I want, right? And then steal all our money. And that's like kind of the whole point of using a Lambda, is that we can prevent against those kinds of attacks. So if we go back, but yeah, again, we're not going to do that because it's a lot of work, and it's not important for testnet. So then we can return to our wallet flow. And now it's time to make the HTTP request to Shinami service to associate the gas transaction, or to associate the transaction bytes with the gas object and get the new transaction bytes back. And now it's time to actually log into Shinami. So at the moment, I don't believe that Shinami is fully released. I have a trial account, so it's entirely possible, and I think pretty likely, that by the time anybody watches this and you're able to get or if you're ever able to get a main account, like a regular account, then this UI might change completely. So I'm not gonna super focus on doing everything exactly as you would do it. Instead, I go to this gas station tab. It makes me create a fund on testnet with, you know, and it needs to have a certain number of credits sent there. So if I through this modal, it tells me, hey, here's this wallet that you need to send testnet tokens to, and then I just sent, you know, from using this, or using like the regular wallet, I sent 20 sweet to this address. And the other thing we care about is this access key and give it the name, tell it we want it for a gas station on that specific fund. So in order to pass the API key onto Shinami when we're making the request to their API service, we're going to need to be able to get it through the Lambda handler. And in order to do that, we're going to use this thing called AWS Secrets Manager. So we're going to use AWS Secrets Manager help, and that's going to give us a list of things that we can do. So yeah, it tells us we can, we're going to want to do create secret. So we have AWS Secrets Manager, create secret. And we have to give it a name, so we have to give it, we're going to give it Shinami key, and we're going to secret string of the of this. This is our actual key. The reason why we're doing it in AWS Secrets Manager is because this is the recommended way of doing it through AWS. And this makes it a lot easier compared to this .env situation. Like, this makes it a lot easier to do things like rotate keys. It makes it easy to just get like this kind of secret wherever you are, like if you're using S3 or Lambdas or whatever you need. And this is definitely the way that you want to do things instead of environment variables. And actually, you can't even do environment variables in the same way in this AWS Lambda as you can with the front end. So we just created a secret. We gave it a name of Shinami key, and we have this ARN, which I believe stands for Amazon Resource Name, which is a fully qualified name to the thing that we just created. And we're going to need to add this ARN to the template.yaml in order to make it accessible by our Lambda. And in order to do that, I just typed out this long policy on the function again. So this is the definition of our get gasless transaction function. We're saying it has a property of a policy, and that policy allows it to get the secret value. And we're specifying the secret Amazon resource name of, and this is substituting in. This is like, think of this as sub. This exclamation point sub is like a template string, right? The SAM like system is substituting in this template string when we run the build command, the SAM build. And this is going to specify that we like the region, the account ID. Just note that this is basically the same thing as this ARN, except that we're making it more generic by adding in these substitutions. But if you only used it on US East 1, which we are using right now, then you actually don't need to make these substitutions at all. So now the second thing that we have to do is we have to go into the get gasless TRX, and again recall that these are all separate npm packages, and we need to install this AWS SDK, and that's what's going to let us actually get the secret inside of the Lambda. So we go back to app.ts. We're going to import AWS from AWS SDK, and then we're going to say we're going to define the variable secrets manager to be a new instance of AWS. And actually, let's change the import here. We're going to directly import secrets manager, and yeah, just instantiate that. So secrets manager. And now inside the body of our lambda, we're going to do secrets manager dot get secret value. We're going to pass it in the secret ID of, we called it, right, Shinami key, so the name. And then by default, Shinami key. This is some kind of weird request object, and we want this to be a promise. So we're going to do, we're going to do await. So we do that, and then we have to unwrap the secret string. And at the moment this is string or undefined. We want to do the same thing here, where if there is no Shinami key, then we're going to return an error, and this is going to be a 500. We're just going to say internal server error console.error, and then we're going to console log something, and we're going to say could not find Shinami secret, or Shinami key secret. So that makes it, that's going to make it easier to debug this. Great, so now that we have the Shinami key, it's time to integrate the actual Shinami API. So Shinami unfortunately does not have an easy to use TypeScript SDK, so we're going to have to use this package called npm I typed RPC. So I'm going off of this sponsored examples TS example code that they provide, and it looks like up here, yeah. So it looks like the way that they're doing JSON, that they're giving you some kind of sponsor SDK is this. And it's possible by the time this video comes out, again, this is pretty new, that they'll have improved this, because this is a little, it's definitely a little bit unwieldy that they don't have this example code out there for us, and we have to adapt it, but, you know, oh well. So RPC client, this is something we import from RPC client from typed RPC. Yeah. And we're going to change this to, they give us this URL, so this is the gas with the gas access key. And we're actually going to, we want to not define this until we know that we're going to have, that we validated everything, and we know that we have a Shinami key. So we're just going to add concatenate the Shinami key, and yeah. So what we just did is this call, this RPC client, we're giving it the type of sponsor RPC. What this is that this is a generic, like RPC, it stands for like remote. What does RPC stand for? Does RPC stand for? It stands for remote procedure call, right? That's right. So what RPC is it's a specific protocol that's used not just in crypto, but across kind of everything, every kind of server-side technology. Is that it's a specific format and way of interfacing with some kind of backend service. So this is a generic JavaScript SDK for interfacing with any kind of RPC, and it looks like the way that this works is you define you define some types. So these are type definitions about what, like, this is a specific RPC method in the same way that, like, the SWI would do its own specific RPC methods and its own specific RPC calls. So we define those and we put those in as type parameters to the RPC client along with the URL of the RPC. And then later on we're able to do sponsor dot, yeah, and then we're able to call the methods And then this is basically just a kind of SDK. Personally, I would like if we didn't have to write this ourselves, if the Shinami people would be able to wrap this into some kind of SDK for us. But I'm sure they're well on their way to doing that. Seems like they have things pretty much handled. So we need to pass into this. The first argument is going to be again, what did we say? We said the transaction bytes. Transaction bytes. And the second argument is going to be the address of the sender, so the end user, what is their wallet address. And I actually completely neglected that, so we're going to add that right now. But the third thing is going to be oh, this is the wrong function, so it's going to be gas sponsor transaction block. Yeah, that's why the types weren't correct. Right, so TX byte string, sender string, gas budget number, and that's going to be the limit of how much gas we can do. So in order to get a number, one more useful thing is in your wallet you could look at past transactions, and if we go back to DevNet and we look at our past transactions, for example, like when we place a pixel. We can see that what do we do? Yeah, so I'm pretty sure this is when we're placing a pixel, and it only cost us 0.13 sui. So let's just let's be a little bit generous here. Let's say that 0.015. Just make it as tight as possible. So again, recall that the way decimals work is this value, one with 9 zeros, represents 1 sui, and we want let's get back to that, and we want to set it to 0.13 or 0.013 sui. So that's going to be 0.013. So if we do this as 1.5, that's going to be 0.015. So right now it's 1.015, but we're going to change it to be 0.0105, and it gives us an error. Okay, it looks like you can't do that in JavaScript, so just get rid of it. And yeah, this is going to be pretty close to the exact gas value. Depending on, you might want to make this a little bit higher depending on your specific use case. Like if you have a more complicated, or if you have a function that could have like variable amount of compute. You might want to set it to be significantly higher than like what you believe your average is. But for us, like we're not really doing anything. We're not doing anything that would cost more gas. The more people are using the more users we have. So it's okay to make it pretty close to what our past has been. And the other thing we need to do is we need to copy paste this code in order to get the address. So we're also going to take that as a query parameter. So we're going to do sender address, and we're going to do sender address. Include sender address, and yeah, sender address. It says this is undefined. Why is that? Right. Change this. Sender address. So this is going to give us back a promise, and we can check that promise, return it back. So we do const response equals await. And yeah, so it gives us a sponsored transaction. Let's say sponsored bytes and response dot tx bytes. And also the other change we need to make is go back to quadrants. We're going to add the other URL and copy paste this instead of, we're going to do sender adder. We're going to set that to be wallet dot address. And also, because while it could potentially be undefined, we're just going to say if what this code is going to have the effect of doing is if there's no wallet, it's just not going to run this if statement, and it's going to do nothing. Before I check this code, though, before I build and deploy, we have these headers. We need to enable cores again for the same reason, like so that the browser front end will recognize that this like random URL is valid. And I just deployed and forgot to do that, so I will remind you to do so too before you wait for it to build and make the same mistake I usually do. And that's pretty simple to do. Again, we just have to add these headers. Let's go back here, and we're just going to add them to every single one of these. Like this, like that, and oops. Well, if you're doing this, you probably want to abstract some of this. Like, you probably don't want to do all these object literals. But again, this is a demo project, so we don't really care about all the code being clean. And then that was from the build that wouldn't have worked. So now we do sam build and sam deploy, and then we will come back when this works.
All right, and we're back. I just struggled through a bit of trouble getting this Lambda to work. Initially, I thought it was a problem with cores, so I made sure that all these content type, application JSON, and access control origin is on. And I'd recommend having those on just in case. Cores is something that's a little bit complicated, so I'll link a tutorial in the description to help understand that. It's definitely outside the scope of this tutorial. But actually what ended up being the problem was this Amazon AWS SDK. Previously we were using the AWS SDK v2, but now we need to switch to the AWS SDK v3. And the reason why is I had such a hard time because the Lambdas have this thing where by default, and you can change this, but you probably don't want to. But by default, they only last for 3 seconds, and if they go over 3 seconds, they crash, and they don't give you the best like error of what happened. So first, I was trying to understand like, oh, did my Lambda crash? Did my CloudFront API not go through? And eventually, I figured out, yeah, I was going over the time limit. And the reason why is because for whatever reason, I don't really know why, but whatever reason, when you initialize the AWS SDK, I think it made some kind of like HTTP request. In the old client constructor call for this is making some kind of HTTP call that was slowing down the Lambda. It's going over the 3-second time limit, and that was causing issues. So we actually have a new, this is the AWS SDK v3, and yeah, as you can see, we got rid of the, so this is the new dependency. We got rid of the old AWS SDK dependency, and we are, it's pretty much the same. It's the same kind of idea. It's the same. It looks very similar, except that you construct a client that sends a command object rather than just constructing a client that has an object, has a function on it that makes the call. So this is basically the same, and it's the same idea. The other issue I had is that I actually misspelled. Whoops. Let me go to my wrong file. Go to the template.yaml. I actually misspelled. This was the wrong, I had this wrong previously. And you can double check this. I'd recommend going to your AWS console. This is going to be in your secrets manager, and you can check and then manually verify what your secret key Amazon resource name is. And I just happened to misspell mine, so I fixed that. And then the last thing that we changed with the Lambda was this, instead of before we were just returning the bytes that the gas station signed, but now I realized that we also need to include the signature, not just the transaction bytes, but the signature, right? That's the whole point of doing this in a Lambda, and the whole point of making these RPC calls to get the signature and then passing this back to the front end. So now we're back at the call side of actually, where we made the call to the Lambda to sign the transaction bytes. And we're doing things a little bit differently. Instead of doing the sign and execute transaction block, we actually have 2 separate calls to sign transaction block and execute transaction block. The first thing is again, because we have, we just had the Shinami Gas Station sign the transaction. So that means that this transaction is allowed to use objects owned by the Shinami Gas Station, and that's what associates the gas object with this, and what makes that association valid. So now we need to sign the transaction so that the RPC knows that we put our source of a stamp of approval on this. And then finally, once we have our signature for the transaction block, then we execute the transaction block, putting both our signature, the sender signature, and also the response signature that the gas station gave us, along, of course, with sponsored bytes. And again, let's just give it a little demo. I understand it might be a little bit hard to see. Apologies, but it is there, especially if you zoom in. It might be hard on mobile, but now we can close this. Now we can, just control clicked on a pixel, and now we approve. It will say, depending on your wallet, it might say that you have a gas budget, but note that this isn't actually going to be, this is not coming out of your account, it's coming out of the other account. So just hit approve, and now we can tell that if you double check, before we had 7.651 testnet sweet tokens, and then after this we're going to have the same amount. So just to double check, 7.651, place a new pixel, control click, two should up, only sign one, approve. Even though it says 0.015 sweet, we can go back. We can see that the transaction just went through. Oops. And 7.651 sweet. So thanks so much for watching. Really appreciate the patience that you've had with me. Really appreciate, working through me, especially AWS. It's not always the rough experience. We're pretty, it's not always the nicest experience. We're pretty early on in the chain still. So, but all that really means is that there's a lot of opportunity out there. So I'd like to, again, thanks all for watching. And this is the end of the gas station sponsored video. Again, please leave any comments if you have any concerns or questions. I'd be happy to answer them, and always love to talk to people about what's going on and what you think should be built on Sweet.